Welcome to The Explainer. I am genuinely so excited you're here today because we're tackling one of the most persistent, honestly frustrating challenges in software engineering and AI orchestration. I'm talking about that massive disconnect between what we tell our systems to do and how we actually document it. Today, we're exploring the Eternus architecture. It's a fascinating system that literally turns standard Markdown documents into executable logic for AI agents. And we aren't just looking at this as some abstract theory, we're looking at a toolkit of practical, implementable patterns for safe AI orchestration. Okay, let's dive into this.
Here is our roadmap for today. We're going to cover the code document divide, Markdown as executable logic, multi-dimensional metadata via glyph chain, ledger-first operational auditing, schema-driven AI execution, and finally, a blueprint for safer AI. Let's get right to it.
Section 1. The code document divide, the separation of machine and human readability.
You know the struggle, right? This is a universal pain point. Modern systems constantly suffer from state collapse, opacity, and this really persistent divergence between the logic the machine runs and the documentation that we humans actually read. Traditional software engineering rigidly separates these two worlds. On one side, you've got your code. It's machine executable, sure, but unless you're a developer actively deep in that specific module, the semantic intent is totally opaque. Plus, the inline comments, they're frequently stale. Then, on the other side, you have the documentation. It's human readable, it's semantic, it's clear, but it's completely ignored by the compiler. Because of this strict separation, what the machine actually does rarely matches what the humans are reading in the company wiki. We just end up with massive compounding synchronization debt.
So, this brings us to a pretty radical question. What if your documentation was the code? Seriously, what if the exact same Markdown file you read to understand a system was the literal, executable layer that an AI agent ran? This completely removes that clunky translation layer between humans and machines, and that is the core paradigm shift of the Eternus Vault system, bridging the gap between specification and implementation once and for all.
Moving on to Section 2. Markdown as executable logic. Introducing the Voltron pattern.
The formal definition of the Voltron pattern is this: declarative Markdown documents acting as executable contracts interpreted by schema-bound AI agents. Now think about what that actually means in practice. It totally challenges the fundamental assumption that specifications and implementations have to be separate artifacts. Here, the text file is the application. By treating standard Markdown as an executable contract, developers can audit the exact instructions the AI was given in plain English. This completely removes the black box nature of prompt engineering. You are quite literally running the document itself.
But I know what you're probably thinking. How does this actually perform in the real world? Well, the researchers implemented it in Eternus, where AI agents act as deterministic interpreters of the Markdown, and the metrics are incredibly grounded. In production, document processing time is just around 50 to 200 milliseconds. The routing is an O of 1 operation based purely on the document schema ID. By executing the Markdown directly, it completely eliminates that code document synchronization debt we talked about. And remarkably, through an integrator operator system, it forms a Turing-complete computational model. Why does that matter? Because since it's Turing-complete, developers aren't limited to just simple fetch commands. You can build complex, looping, conditional AI workflows entirely out of structured text files. It's fast, it's practical, and it's highly scalable.
Section 3. Multidimensional metadata via glyph chain, structuring the symbolic state.
Now, what's really interesting about this setup is how glyph chain acts like Git metadata on steroids. If you're going to execute Markdown, you absolutely need a rigorous way to track state, meaning, and provenance. Instead of just slapping on a timestamp and an author, glyph chain uses 12 orthogonal axes embedded right into the Markdown front matter. Notice the 3 critical ones detailed here. The T-axis provides a strictly monotonic temporal index, so execution ordering is guaranteed without needing a centralized clock. The S-axis maps out the semantic meaning and topic, and the prov-axis enforces cryptographic lineage and source tracking. Let me give you a quick micro-example of why this is a practice you should definitely care about. By enforcing cryptographic lineage on the prov axis, an AI agent can instantly verify if a document was tampered with before it even tries executing it. Every executable document is safely anchored in this 12-dimensional coordinate system.
And the impact of structuring it this way is massive. The researchers observed a 94% reduction in metadata ambiguity compared to traditional timestamp-only systems, and that was evaluated across a production deployment of over 5,000 documents. To tie this back to your own AI implementations, Reducing metadata ambiguity directly translates to fewer AI hallucinations and drastically reduced routing errors when you're managing thousands of files. You always know exactly when, why, and how a document is operating.
Section 4. Ledger-first operational auditing, ensuring pre-execution safety.
In traditional software, we log an event after it happens. Makes sense, right? But with AI systems, non-deterministic failures are super common. If a system crashes or hallucinates during execution, the log is never written. The operation just becomes a ghost. Eternus solves this by making auditability an architectural prerequisite. They use a pipeline that looks exactly like a strict accounting ledger. Step 1. Declare the intent of the operation. Step 2. Write a pre-execution receipt to an immutable ledger. Step 3. Then execute the operation. And Step 4. Record the outcome back to the receipt. By writing the receipt before the LLM even touches the markdown, you guarantee a permanent trace of the intent, even if the AI completely crashes during execution. This is a highly valuable practice for any development team to adopt.
So the crucial point here is that this ledger-first approach works flawlessly in practice without slowing you down. Across 1,247 operations tracked in their study, there was 0 missing receipts. None. The median write latency was just 0.4 milliseconds. This means it has an amortized O of 1 performance overhead. Basically, the computational cost is so flat and negligible, it doesn't scale up as your system gets busier. Because the ledger captures the human-readable intent alongside the execution trace, it enables perfect time-travel state reconstruction. Let's look at this practically. Because every state change is pre-logged with human-readable intent, if your AI agent accidentally corrupts a database at 2 p.m., you can confidently rewind and rebuild the exact pristine state of your system at 1:59 p.m. It is the ultimate fail-safe practice.
Section 5. Schema-driven AI execution. Polyglot symbolic programming. And this brilliantly illustrates the concept of schema-driven execution. How do you actually govern how an AI reads the markdown? Well, you do it through behavioral polymorphism, dictated entirely by the document's metadata schema. The exact same markdown syntax can drive entirely different AI behaviors. For instance, if a document uses schema FM v1.3, the AI interpreter knows to apply a creative, flexible, and metaphorical focus. But if you update that metadata to schema FM v2.2.2, the AI immediately shifts to a deterministic, rigid execution mode requiring formal compliance. For developers, this means you can use the exact same vault of documents for creative brainstorming with one agent and rigorous data compliance with another, literally just by swapping the schema version in the header. The schema itself acts as a first-class behavioral contract for the AI engine.
Section 6. A blueprint for safer AI, integrating the patterns for production.
Okay, so how do we integrate all these patterns into a production environment that is actually safe? Eternus builds a comprehensive safety stack directly on top of this Markdown foundation, and these are practices you can absolutely learn from. First up, they use DragonHax operators. Instead of just blindly trusting an AI not to loop infinitely, DragonHax operators act as hard-coded symbolic markers in the text that forcefully cap recursion and prevent runaways. Next is the input types ingress canon. Now, this isn't just basic data validation. It guarantees that any external data handed to the AI has a cryptographic proof of user consent permanently attached to it. Then they employ an engine activation protocol. This acts as a strict gate that prevents undocumented drift by requiring rigorous structural checks before any new modules can even come online. And overarching all of this is the Sovereign Congress. This practice ensures that no single rogue agent, or even a single developer, can alter core system logic without cryptographically verified multi-signature approval. By implementing these specific boundaries, you can maintain incredibly robust operational coherence, even in the most complex AI ecosystems.
As the research states so perfectly, the Voltron pattern challenges fundamental assumptions, opening new research directions where human-readable documentation serves simultaneously as executable implementation. Unifying what humans read with what machines execute fundamentally cures the opacity of modern AI orchestration. It's a real game changer.
As AI agents become the primary interpreters of our systems, the divide between code and documentation is rapidly disappearing. So the question is, how will you implement these deterministic, executable markdown patterns like ledger-first auditing and multidimensional metadata in your own AI workflows? Thank you so much for joining me on this explainer. I hope you found these architectural patterns as practical and, frankly, as fascinating as I did. Keep learning, keep building, and I'll see you next time.